All right, welcome in everybody. Welcome into our class, our first class of 2 for proportions. So for anybody here who might be familiar, might recognize a proportion, but you're not exactly confident on solving proportions, especially proportion word problems, then this is going to be an amazing class. You know, nothing short of amazing, because we're going to break things down in a way that's going to be really digestible, really easy on the eyes, to help you break down the fundamentals. So the first thing that we're going to do, and you may have heard me say this already if you were here before I started the recording, but number one is we're going to be refreshing on how to solve proportions. So things like this, where we have perhaps 3 over 5 equals x over 50. We're going to learn how to solve these types of equations. Number two, once we learn how to solve proportions, all the different ways that we can solve them, then we're going to learn how to set them up, which entails comparing items correctly. Today's main idea, as you're going to hear me say maybe 500 times today, it's going to be comparing the same things in the same way. So don't worry about writing that down now. We're going to go ahead and write that down in a moment. But then once we have a nice refresher gone by with solving, and we've had a chance to compare the items correctly and learn how to do that, then we're going to bring it all together. We're going to set up and solve proportions all in one in context, and we'll be good to go. So with that said, everybody, let's go ahead and begin taking notes here. So right here, we have 3 main ways to solve proportions. I want you to write all 3 of these down in a moment. Feel free to leave your pencils on the table. Because, first of all, number 1, everybody, who here recognizes this most popular method for solving proportions? Cross, multiply, and divide. Who recognizes that? Give me a yes or no here in the chat box. Yeah, that's a lot of us. I think that's everybody, actually. Yeah, so very common method. Very common method. It will, here's the good thing about it, it'll always work. However, I have to make something very clear, my party people, and it's this. And you know this. Everybody, when it comes to the test, when you actually take the real deal test, are you going to have forever? Are you going to have all day to do it? Yeah, absolutely not. Absolutely not. I mean, I wish we had all day, right? I know a lot of us would score way higher if we had all day, but sadly, that's just not the reality. We get just about 2 minutes and 26 seconds per question, just about. So when it comes to this main method, the cross multiplication and division, sometimes it might take a little longer than necessary. So we're going to also talk about this best method where we try simplifying vertically or horizontally first, not diagonally, but simplifying vertically or horizontally, because remember this, proportions are basically fractions that are of the same comparison or of the same value. So when you have fractions, sometimes you can simplify. And so we'll be going over that as well. But number 3 is going to be the most interesting one here. We always want to look out for convenient comparisons where one numerator is a multiple of the other and you can compare horizontally or vertically. Now, don't worry if that doesn't make too much sense right now. I promise you it's going to blow your mind in a few slides. But what I want you to do, everybody, is take a moment to write down these 3 strategies, and then we're going to get straight to it. We're going to solve some proportions in real time, and we're going to really implement these 3 strategies, and I'll let you pick your favorite one. I'll let you pick the one that you're most comfortable with, and we'll roll forward with it. So go ahead, write this down, and we'll move forward momentarily. All right, so let's get those hands dirty, and let's take a look at this proportion here. We have this equation here where we have a fraction, 3 over 9 equals the other fraction, x over 27. So let's go ahead and take care of business. So the first strategy that we went over was that classic strategy, cross multiply and divide. So here's what that's going to look like. Let me zoom in a little bit and let's get this done. So cross multiplying and dividing, here's what that looks like. I'm going to take a diagonal line and diagonal line, and we're just going to multiply those. So we have 9 times x. Just as a quick little refresher, 9 times x is going to be written as what? Yeah, it's going to be written as 9x. That's right. So let's write that down right over here. And there we are. And then on the right side, we are going to be doing 3 times 27. Now notice that 3 times 27, I think it's fairly reasonable to say that not everybody's going to know what that is off the top of their head. You might not. So what some folks might need to do is go ahead and multiply that on the side. Now I'm doing this on purpose. I'm showing this on purpose to show you this is what it looks like when we take extra time. Now, if you work on your mental math a ton, this can go by a lot faster. But I'm just showing you what happens to the typical test taker in this scenario. So we'll do 7 times 3, and that's going to be 21, carry the 2. Then we have 2 times 3, which is 6, and we'll carry that 2 right there, which is 8. So we have 9x equals 81. Now, in this situation, after we cross multiply, everybody, what are we supposed to do again? We're supposed to cross multiply and then divide. That's right, Giovanni. So with that, we're going to divide both sides by the number in front of that x, that variable. It might not always be x. It's really up to you. You can have A, B, C, kangaroos, potatoes, doesn't really matter. But we're going to divide by that number in front of that variable. So let's go ahead and get that done. And we divide by 9 on both sides. And what's going to happen is we cancel out on the left. When you multiply and divide by the same thing, we end up canceling out. So that's what's going to leave us with x by itself. And then 81 divided by 9 gives us our final answer, which is going to be what? Yeah, it's going to be 9. And there we are. So x equals 9, and we're all set. So my party people really quick, was that painful or painless when it comes to refreshing on cross multiplying and dividing? Yeah, pretty painless, right? Relatively painless. It takes a little while for sure, yeah. But that's only because the people saying that know better. They know what we're about to do, so you're good. So with that, I want to go ahead and show you that although this is, again, a solid strategy, there are ways that can save you time if you know what you're looking for. So let's go ahead here and let's rewrite let me just clear out the proportion just like this. And I'll show you technique number 2. Let me just draw a little vertical line to make some space. So here's number 2. Everybody, when we take a look at 3 over 9, let's focus in on that. Let's really focus in on 3 over 9. Everybody, what's that S word that we just got done writing down in the previous slide? Yeah, simplification. We can simplify. We can absolutely simplify. And when we take a look at 3 over 9, let me just highlight that in green. When we take a look at 3 over 9, we want to ask ourselves, hey, what number can we divide into both 3 and 9? Somebody tell me. Yeah, that's going to be 3. We can divide 3 out of each 3 and 9. Nice and easy. So let's go ahead and do that. Let's divide out right here. Divide 3 on both the numerator and denominator. That's how simplifying works. Whatever you do to the numerator, you do to the denominator. Whatever you do to the top, you do to the bottom. So here, let's go ahead and get that done, everybody. What's 3 divided by 3 going to give us? That's just going to be 1, exactly. And then 9 divided by 3, what's that going to give us? That's going to be 3. 3 times 3 is 9, so 9 divided by 3 is 3. So look at what just happened. We just took a quick second, a very quick moment, to simplify that fraction, and now we have 1 over 3 equals x over 27. Quick question, everybody. If I were to cross multiply and divide from this point, is it going to be easier in this case than it was earlier, in your opinion? Oh yeah, it's going to be easier. Absolutely, because remember earlier, when we cross multiplied, we had 3 times 27, and we had to take the time to write out that multiplication on the side. But look at what happens if we notice. In case you do notice, look at the reward that you get. A much simpler, much easier cross multiplication and division. Let's go ahead and try that out. Let's see what we got. So I'll go ahead and cross multiply 3 times x. And I think I can speak for all of us when I say that 3 times x is going to be 3x. But then here's the quote hard part, right? Instead of doing 3 times 27, we have 1 times 27. And 1 times 27 is just going to be 27. Nice and easy. So we skipped the whole part where we had to write down the multiplication. And then lastly, 3x equals 27. We just got to divide both sides by 3, and we're good. Help me out, everybody. What's 27 divided by 3? Look at that. And we get the same exact answer. Same exact answer as before. 9 before, 9 still. So, does it make sense to us, generally speaking, that if we can simplify when it comes to solving proportions, that we should? Because it'll end up saving us time, especially as we start dealing with larger and larger numbers. Simplifying first gives us a simpler cross multiplication. Yeah, absolutely, Shane. So as a reminder, simplifying is when you are essentially looking at a fraction and you're doing this. Let me go ahead and show you. Everybody, quick question. Is it true when we look at 5 over 10? Is it true that 5 is half of 10? Is it true? Yeah, absolutely, right? 5 is definitely half of 10. Well, is there another way to write 5 over 10? Absolutely. We can write 5 over 10 as 6 over 12. Why is that true? Well, because 6 is half of 12. It's the same comparison. You are looking at half over here because 5 is half of 10. 6 over 12, that's half as well. But instead of getting bigger and bigger, here's what simplification does for us. Simplifying lets you write the same value, but with smaller numbers inside of this comparison. And this is really valuable because we all want to, we all wish that we were dealing with 1 plus 1 on the test, right? We all wish that it was as simple as 1 plus 1. Simplifying helps you get closer to 1 plus 1. So what we can do is when you simplify, you divide the same thing on the top and the bottom. Whatever you can divide is what you will divide. Typically, you want to go with the biggest number that you can divide out. And once you do that, watch this. 6 is half of 12, but when you do 6 divided by 6, that's 1. 12 divided by 6, that's 2. Everybody, is 1 half of 2? Yeah. These are all the same value. 5 over 10, take your calculator out. That's 0.5, that's half. 6 divided by 12, do that in your calculator. That's 0.5 again. 1 over 2, that's 0.5, that is half. But this is what we would prefer to deal with over these two. So that's the point I'm making, everybody. We want to be able to deal with simpler numbers where we can, and that's where simplification really gives us that advantage. Let me know, for those of us that had the question in the chat box, does that make a little more sense for us? Before I try to rearrange your brain with the third part. All right on. So let's go ahead and do this the third way. Let me draw one more thing here. And everybody, here's what's going to happen. What we are about to do is we are about to compare the same things in the same way. So allow me to just write this fraction all over again. Let me duplicate that right over there. And we're going to write 3 over 9 equals x over 27. I'm going to be very serious when I say that I'm going to solve this problem faster than it took me to write down the proportion. Here's how. Everybody, quick question. If I compare left to right, what do I multiply 9 by to get to 27? Giovanni says 3, and so does everybody else. Okay, so I'm comfortable with saying yes. To go from 9 to get to 27, left to right, I multiply by 3. Again, let me repeat myself. I started on the left side, and I went to the right side. Left to right, I saw that the relationship, the comparison, was multiplying by 3 to go from the left side to the right side. Now, here's what happens, everybody. You are going to compare the same things in the same way. If the relationship left to right is times 3 on the bottom, well, it's going to be the same relationship up top. It has to be. Legally speaking, if there was a claw and order with math, this is always true. If you go left to right on the bottom times 3, hey, it's going to be times 3 left to right on the top. And guess what, everybody? What's 3 times 3? What is 3 times 3? Oh, look at that. It's going to be 9. Look at that. Was that the same answer that we got before? Oh, yes. Look at that. That's how easy it can be if you notice the convenient situation. Here, let me go through it again. You want to compare the same things in the same way. The comparison that we went through was, hey, from left to right, we notice the relationship of times 3. So what that means must be true is that if you go left to right on the top, if you compare it the same way on the top, it's the same comparison, times 3. 3 times 3, that gives us 9. Boom, and that's it, and we're good. Again, this is noticing convenient situations, but I promise you, you'll run into at least one of these on your test. And here's the great thing about it. It's not just left to right or right to left. You can go bottom to top, top to bottom. Let me go ahead and prove it to you. This is how cool this can be if you know what you're looking for. So let me just duplicate this. Let me put that right over here. And don't worry, I'll go ahead and zoom out to give you the opportunity to take screenshots. So here's the thing. When we talk about comparisons, the comparisons can be multiplication or division. So it can be multiplication or division. Either way, just make sure that you compare the same things in the same way. If I had a clicker here for a counter, yeah, I probably said compare the same things in the same way probably a dozen times. So let me go ahead and show you here. I can go top to bottom or bottom to top. Everybody, quick question. How do I go from 9 to 3? Again, hear me out. Starting from 9 to get to 3, am I using multiplication or division? Am I using multiplication or division? If I start from 9 and I try to get down to 3, yeah, division. So let me write out the comparison. Starting from 9 to get to 3, I divide by what value? What number am I dividing by? Yeah, I'll be dividing by 3. This 3 and this 3 are just coincidences. They are not the same 3. It's just a coincidence, and don't worry, we'll have plenty more examples to work through so you see it's not a coincidence. So here, guess what? If we're going bottom to top, divide by 3, guess what has to be true as well? If I start from the bottom and try to go to the top, I am dividing by 3. Help me out, everybody. What's 27 divided by 3? I know someone knows. Yeah, that's going to be 9. X equals 9. So notice how I didn't even write any complicated equations. I didn't divide both sides, didn't cross multiply, didn't have to do anything. If I notice the convenience of the situation and I know how to compare the same things in the same way, that's number 13. If I compare the same things in the same way, number 14, then we are good. We can find some of these convenient situations and really take advantage of them. So my party people, even if we don't entirely, completely, 100% understand all 3 of the methods, do you understand in your heart that there are more than one way to get the job done? Good. As long as we have that fundamental understanding, I promise you, all 3 of these will soon be understood with some practice over time, and then it's going to be up to you to stick with your preferred method. So I'm going to say this clear and cut right here. If you prefer cross multiplying and dividing, and that's what you like to do, hey, stick to it. Get good at it, get really good at it, master that. You just have to make sure you're quick at your calculations because you have to make up for the extra time you might take using this. But if you want to commit a little more time and effort into your mental math, into understanding simplifying fractions and comparing the same things in the same way, you will be rewarded greatly in terms of the amount of time that you'll save. Because guess what, everybody? Do I have to actually write this comparison down if I have enough practice? Do I have to draw this arrow from left to right to actually prove that the comparison is there? No. I'm writing this down because I'm teaching you. But as you get better at this, you won't have to write this down all the time. You'll be saving all the time in the world, and that way you can make the easy problems look easy and save more time for the harder ones. So with that said, everybody, I'll give you a moment here to go ahead and screenshot this, write this down, and then we are going to get straight into the next example problems where we'll go ahead and use cross multiplication, simplification, or comparison, whichever is more convenient for that situation. And again, I'll clarify, Gina, the direction doesn't matter. You can go from left to right, just make sure you are consistent left to right on the bottom and top. If you go right to left, just make sure you go right to left on the other side as well. If you go top to bottom, the other side has to be top to bottom. If you go bottom to top, make sure the other side is bottom to top. Yep, consistency matters every day. All right, so here's example number 2, my party people. Let's go ahead and get this part going. So before we even cross multiply and divide, before I even do all that, before I even simplify, here's what I can show you. I can notice immediately that I can do a quick comparison. I can compare. I noticed that if I'm trying to get to this x here, I can try to go left to right, or I can try to go bottom to top. I can go left to right or bottom to top. And the good thing is, in this situation, both ways are going to work. Both ways will work. So let me show you how. Everybody, if I wanted to go left to right to get to x, I can try going left to right over here and see if there is a convenient comparison. Everybody, is there a convenient way to go from 10 to 20? Yeah, that's going to be times 2. So we can write that comparison like that. I multiply by 2. And just remember, whatever we do on the bottom, we're going to do on the top. We're going to compare the same things in the same way. So allow me to duplicate this because it's the same exact comparison. I noticed that to go from 10 to get to 20, that's times 2. So that means that the same rule is going to apply up top. Everybody, 5 times 2 is going to be what? Booyah. And there's your answer. That's going to be 10. X equals 10. Don't believe me? Let's go ahead here and cross multiply and divide and see what happens. So here we go. Let's cross multiply. 10 times x, that's going to give me 10x. Then 5 times 10, or 5 times 20, excuse me, everybody. 5 times 20 is going to give us what? Yeah, that's going to give us 100. So we have 10x equals 100. And then the last thing that we need to do here is divide both sides by 10. Again, divide both sides by that number in front of the x to get rid of everything around the x, just to get x by itself. So if I divide by 10, cancels out on the left side, and we get x equals 100 divided by 10, which is 10. So look at that. Again, cross multiplying and dividing, it always works. It always works. So when in doubt, cross multiply and divide. When in doubt, you have everything in your power to do that. But when you notice the convenient comparisons, take advantage of that moment. Does that make a little more sense, my party people? Hey, right on, my party people. There we go. So yeah, you can absolutely keep practicing this. This may not be in the math basics course because we focus on other things like primary fractions, adding, subtracting, multiplying, dividing. This will be in your AR course, the proportions unit, which should be unit number 2. So write that down for those of you in the program. Again, you can get a ton of practice with this. Arithmetic reasoning, unit number 2. So let's take a moment here and move over to the third example. And let's keep the good vibes going here. So here we have something a little more awkward. We don't have super easy numbers, but we can still find it here. Because when we try to take a look, everybody, can we simplify 2 over 7? Is that possible? Yeah, 2 over 7, you can't really simplify that. These are both prime numbers. Can't do that. Don't have factors there. We could just straight up go cross multiplication and division. We could. 2 times x, 2x. 7 times 10, that's 70. But now we have to go ahead and divide both sides by 2. And not everybody knows what 70 divided by 2 is instantly off the top of their head. Most of us, some of us know for sure, but not everybody. But that will be 35 if we do that. If we divide by 2, we'll have x equals 35. But here's the thing. If you notice, because this is not always going to be true, if you notice that there is a convenient comparison, take advantage of it. It takes 1 to 3 seconds to look at the proportion and realize if you know it, you know it. If you don't, you don't. But if you do see the comparison, look at how easy things can become. I'm trying to get to x. So I can try going left to right, or I can try going top to bottom. Everybody, first, you tell me, is there an easy whole number that can get me from 2 to 7? Is there an easy whole number that I can multiply 2 by to get to 7? No, there isn't. There's not a whole number that I can use. So instead, let me try the other way. Instead of trying to go from top to bottom, which I knew I couldn't find a comparison, let's try going left to right. So let's take a look up top with the numbers that are actually there. We have 2, and we're trying to get to 10. My party people, how do I go from 2 and get to 10? Remember, your two options are multiplication or division, and then give me a number. I see a lot of us throwing 5 in there, but be specific. Am I dividing by 5 or am I multiplying by 5? There we go. Yep. This specificity, being specific here, is really going to help you out in the future. So in this circumstance here, we can multiply, starting from 2, we can multiply by 5 to get to 10. So again, 2 times 5 gives us 10. That's how I found out that 5 times 5 is the comparison from left to right. So what does this mean? This means that if I'm going to go times 5 from left to right on the top, it is going to be times 5 left to right on the bottom. Let me go ahead and actually point this out right here. Right there and right there. It's the same comparison. It's the same comparison in the same direction. Same comparison in the same direction. That's what makes this so convenient. Because everybody, now that we found the comparison up top, we know it's the same comparison on the bottom. Help me out, everybody. What's 7 times 5? 35. Booyah right there. X equals 35. And we didn't have to go through everything that we went through over here. We didn't have to. We didn't have to because we found the convenience in terms of the comparison. So after this third example, everybody, who's feeling a little better now about this? Good. And I like that question there. I like that question from Gerald. Does long division play a factor as well? Absolutely. When it comes to straight up cross multiplying and dividing, which again, sometimes you're going to be forced to do, think about it. It's not always going to be 70 divided by 2. What if it's 1,439 divided by 12? Well, yeah, you're going to have to do long division. You know, you're still dividing. You're just using long division to do the larger numbers in that way. All right, my party people. So are we ready for another example to give a shot at this? Let me see how many more examples we have left, actually. Let me see here. We have 2 more good, convenient examples to work for here. All right, so let's take a look here at another example here. Before we start getting into word problems, I think we're hitting a pretty good rhythm. And just remember, everybody, let's make sure that this is drilled into our heads. Let's say that you can't find a simplification, even though there is a simplification here. Let's pretend that there wasn't. Let's also pretend that you couldn't see a clear comparison like I've been trying to, really express. What is the default fallback method? What is the default, everybody? What's it going to be? If you can't simplify, if you don't see a convenient comparison, what should we always resort to? That's right, Shane. Cross multiplication and division. Whenever it is, it is not convenient or simplification just isn't there, cross multiply and divide. So let's go ahead and do that first here. Let's go ahead and cross multiply y times 20. That's going to be 20y. Then we have 5 times 4. And look at that. That's going to be 20. So if we were to go ahead and divide 20 on both sides, because again, we already cross multiplied. Now we're dividing. So when we divide both sides by 20, on the left side, it's going to cancel. Nice and easy. And on the right side, 20 divided by 20, or any number divided by itself, always equals 1. And so the correct answer here would be y equals 1. And there we go. So that's, again, the primary way to do it always works. It's just a matter of how long it'll take. But now let's take a look at the other ways that we could have possibly gotten this done. The second way, it would have entailed trying to simplify. Everybody, when it comes to 4 divided by 20, is that a fraction that can be simplified in your opinion? Yeah, absolutely. So again, I'm going to reiterate, you can always, every single proportion, you can always cross multiply and divide. Always. Simplifying first and comparing, that is possible. It's not always a guarantee. It is possible depending on the numbers you're dealing with. In this circumstance, yeah, we can simplify because 4 and 20 are both divisible by what? 4 and 20 are both divisible by... I think a lot of y'all are writing down what 20 divided by 4 is. But what are they divisible by? What's the biggest number that they're both divisible by? 2 works, But the bigger number, the biggest number that we can use, yeah, it's going to be 4. 4 divided by 4, that's possible. 20 divided by 4, that's possible as well. So we can simplify this fraction here. Let me just use a little highlighter. Let me just go ahead and use purple there. Let's simplify 4 over 20 by dividing the 4 and the 20 each by 4. Again, whatever you do to the numerator, you can do to the denominator. And so once we do that, well, 4 divided by 4, that's going to end up being 1. And then 20 divided by 4, that's going to end up being 5. And look at that. Once we simplify, we have a pretty good perspective here, a pretty good view of what the answer might be. Because everybody, if this is supposed to equal this, if both of the denominators, if both of the bottoms are 5 and this top part is 1, what does this have to be then? Again, if this side equals this side, yeah, if each of the denominators are 5, that means that each of the numerators have to be the same. If this side is 1, this side has to be 1, which we discovered already to be true. So look at that. Simplifying can get us into some pretty convenient situations when you're able to simplify. But again, let's say that we weren't able to simplify or we chose a different method. Okay, no problem at all. Let me just write the original here. Y divided by 5 equals 4 divided by 20. Here's what we can also do. I'm trying to get to my final answer right here, my Y. So you can try to go from right to left, or you can try to go from bottom to top. Either way, you're trying to get to that answer. So if I'm going to go try to, do right to left, I'm going to ask myself right to left over here. Everybody, how do I go from 20 to 5? How do I go from 20 to 5? Yeah, we can divide, and we can specifically divide by 4. That's right. That's absolutely right. So let's go ahead and try that out. Let's give it a go. I can see, let me use blue again, that going from 20 to 5, that's a division of 4. Because again, hear me out, 20 divided by 4 gives us 5. So with that said, if it's divide by 4 from right to left on the bottom, it's going to be the same thing up top. Right to left, divide by 4. Everybody, what's 4 divided by 4? Yep, that's going to be 1. Booyah. And we can get that conveniently just like that. And what's also convenient about this problem is we can also go vertically. Here we went horizontally, right to left. We can also go bottom to top. Everybody help me out. How do I go from 20 to 4 with multiplication or division? How do I go from 20 down to 4? Yeah, that's division again. And we're going to be dividing by 5. So there's the comparison, everybody. To go from bottom to top, we divided by 5. So that means on the left side, we are going to divide by 5 from the bottom to top, because we did bottom to top divide by 5 over here. So it must be true on the left side. Divide by 5, and look at what happens. 5 divided by 5, everybody, is what? Yeah, simply put, it's going to be 1 again. So take a moment here, everybody. There are 3 separate techniques to accomplish the same thing. Do you technically have to know all of these? No. I just recommend that you learn how to do something in more than one way, because this is always the go-to cross multiplication and division, but sometimes it might be mighty annoying to take a long time, especially if we know these other 2 techniques. So I'll ask again before we move forward here into the word problem part of class, because we're now at the halfway point. So we're going to move forward to word problems now. But I want to ask us, is the solving proportions, is it clear to you that, hey, I have my favorite technique. I have a technique that I'm going to look to use every single time. For you personally, good. And even if you're feeling iffy, don't worry. You're still in a great position because you're willing to try. As long as you're willing to try and you're willing to learn from your mistakes, you're in the perfect place to do it. I'd rather you make the mistakes here than make the mistakes on the actual test. So remember, give yourself that patience, give yourself that grace. You got this, and we'll make this the best we can. So with that, let's go ahead and turn over to one last page of notes. And it's going to be a pretty easy one. It might be pretty recognizable, and this will be the 50th time I've said this today. Setting up proportions, here's the main idea. compare the same things in the same way. Again, compare the same things in the same way. Take a moment, write that down, because that's all you need to write down for proportions, and we're going to get into word problems shortly. All right, my party people. So now that we are done writing down our notes, which, we all clearly did because we all wrote it down in the chat box after the fact, let's go ahead and take a look at our first word problem. So here's the one thing that I haven't really expressed yet in today's class, but I always express in every class, and it's the main strategy for word problems. Yes, I see everybody in the chat box typing in RTQ, and that's step number one. Step number one is read the question. And remember, everybody, this is not a question. This is a question. You want to read the question sentence first, not last. Because remember, you're basically walking into a lion's den here, and it's best to understand how to tame that lion instead of sitting and reading and twiddling with your thumbs and letting that lion jump on your back. That's the worst thing you can do. Before you walk into that room, if you understand how to tame that lion or what to do to tame that lion, then things become a lot easier. Time slows down a little bit, and you'll see that overall, word problems feel easier. So here we go. Here's the question sentence. How many units of red paint are needed? Can everybody here confirm that we are looking for the number of units of red paint specifically? Good. Notice how much easier it is. I don't know how I'm going to do it yet. I have no clue. I mean, I do, sure. But I'm going to pretend that I have no clue right now, other than the fact that I know what I'm looking for. So right there, let me write that out. I'm looking for blank red units of red paint. Okay. Now, what's going to be important in proportion word problems is noticing any information that's attached to what you're looking for. And notice that there's a comma right there. This is actually going to be the full sentence. If there are 18 units of blue paint, how many units of red paint? Okay, again, they wrote that in the same sentence, so let's write that information together. So we're looking for blank units of red paint, and we also have 18 units of blue paint. So I'm going to write those two pieces of information together. So with that said, everybody, now let's go ahead and understand the information. Because remember, the first step is the question. What do we want? Second step is what do we have? What information are we given? And then the third step is we're going to make a connection between what we want and what we have. Again, nice and easy step by step. So here's the information. In a paint mixing project, the ratio of blue paint to red paint is 3:5. Let me help you all out real quick. When we say that the ratio of blue paint to red paint is 3:5, this is a comparison. They're actually giving you a fraction. 3/5, 3 compared to 5, they both mean the same thing. But let me show you the fatal mistake that a lot of people make. Watch this. Here's the fatal mistake that folks make. A lot of people will say, okay, I see 3:5, and I'm just going to write 3 and 5, and I see 3 for red, 5 for blue, and they're going to move forward just like that. And then they're going to set up their proportion, and then they're going to get an answer. And guess what? One of these answers might be there to trick you. Now, let me ask y'all real quick. Is this the right way to write it? I wrote red with red, blue with blue. Again, comparing the same things in the same way, right? I'm doing that, right? No, I'm not. I am not. And here's why I'm not. It's the way a ratio is written. Watch this. The ratio of, let me just change colors here real quick in the background, my party people. Give me 2 seconds. Let me see here. That's going to be blue. Okay, cool. So the ratio of blue paint and that red paint is written second. Everybody, quick question. Which was written first? Again, help me out. Just be clear. Help me out. Which one came first? Blue or red? Which one was written first? Yeah, blue was written first. So when we take a look at the numbers here in this comparison, which number does blue correspond with? Yeah, the 3. The way a ratio is written, The order matters. How else are you supposed to expect yourself to compare the same things in the same way if you don't care about the order? The order absolutely matters, everybody. So if we wrote blue paint first, and then we wrote the number 3 first in the ratio, 3 corresponds to blue. And then red was written second, and so the 5 corresponds to red. My party people, does that make sense? That the order matters in the way that a ratio is written? Good. And I hope you notice that it's all of these little things. It's not, it's not crazy stuff I'm throwing your way, individually speaking. Individually speaking, there are sets of little rules that you have to know that make up the big picture, the big understanding. Let me show you how this is going to help us get the right answer. So first of all, this is wrong. 3 does not represent red. 5 represents red. So I'm going to erase this and put 5 for red. And then I'm going to erase that number for blue, and I'm going to put 3 for blue. So with that, everybody, we have now set things up to compare the same things in the same way. Here's how. When it comes to what I'm looking for, I am looking for red paint, and that's compared with 18 blue units of paint. If we take a look down here, we are comparing red paint to blue paint. Again, up top, red compared to blue. Down here, red compared to blue. I can now write my proportion. And as long as you are comparing the same things in the same way, you can write it however you want. Let me show you. Let me show you. I'm going to use R for red, if that's okay with everybody. Let me write this proportion like this. I can write it as red compared to blue. So R compared to 18 equals red compared to blue. 5 compared to 3. Take a look, my party people. This is red compared to blue, red compared to blue. Does that make sense, everybody, that I compared the same things in the same way? Right on. And let me show you. We can do it a different way too. We can do it a different way too. I can go ahead and compare it like this. I can compare red to red and blue to blue. That works too. I can write R, let me actually just use black and then use green to note it. So R over 5, red compared to red, blue compared to blue in the same way. 18 over 3. Let me write down the comparison for you. Red compared to red, blue compared to blue. Notice we are comparing the same things in the same way. If I went red to blue from the first comparison, red to blue from the second comparison. First red compared to second red, first blue compared to second blue. We are comparing the same things in the same way. And if you don't believe me, if you're a little confused, or if you're just not quite seeing it, I got you. This is my job. It's to help you see what you haven't been able to see. I got you. Here's what we do. Let's go ahead and solve. Let's go ahead and solve. Let's try this. Let me move this one over here, and let's go ahead and solve this one first. Let's try using comparison, everybody. If we try to use comparison, can we solve this pretty quickly? I think we can. I think we can. Help me out, everybody. Let me go ahead and use a different color to highlight. Let me just go ahead and use blue, nice and easy. I'm trying to get to red here. I'm trying to get to red. Everybody, can I go from bottom to top? Can I go from 3 to 5 with multiplication? Nah, that's not going to be easy. That's kind of frustrating. That's not going to work. Okay, don't panic. You're good. No need to panic. Let's see if we can go horizontally. Again, if I'm trying to get to red, I tried to go vertical. That didn't really work. Let me try going horizontal from 5 to R. Everybody, how do I go? How do I go from 3 to 18? Yeah, that's times 6. And everybody, was that right to left or left to right? Remind me, help me out. Was that right to left or left to right? Correct. That was right to left. That was right to left. That was the comparison that I noticed. I can multiply by 6, right to left. Well, guess what? I can do the same comparison up top. Right to left, again, comparing the same things in the same way. I can multiply by 6. Help me out, my friends. 5 times 6 is what? 30. Yes, and we're good. There's our correct answer. R equals 30. Now let me prove to you that I can set it up like this too and still get it right. Let me prove it to you. Everybody, let's say I'm trying to get to R. Let's say I'm trying to get to R. Let's say I'm trying to go right to left. Well, can't go from 3 to 5. That's not going to work. Let me try to go vertical. Let me try to go vertical. Everybody, how can I go from 3 to 18? That's multiplying by 6, right? Yeah, I can multiply by 6. So if I'm specifically going from bottom to top, that's a times 6 relationship. That means it's the same exact relationship on the left side. Everybody, what is 5 multiplied by 6 again? Yeah, that's 30. So look at that. Either way, solving this proportion works because there's multiple ways to set a proportion up. But you have to follow the one cardinal rule, and that is compare the same things in the same way. So I see a couple of comments here, a couple of inquiries asking me, hey, can we go ahead and swap the sides? So are we asking, when you say swap the sides, that if R over 18 was on the right side and 5 over 3 was on the left side? Is that what you're asking? Yep. Yeah. Like if you flip it. Yeah, absolutely works. I think that's a great question too. I love those types of questions. Let me go ahead and show you exactly why that would work as well. Let me write it down. 3 over 5 equals 18 over R. Let me show you why this works as well. I'm going to use capital R. Let me go ahead and let me just erase some of these things here so it's a little less confusing. I got you. I'm going to use a capital R and a capital B for this first line here. So I'm going to use capital R, capital B. For this bottom part, I'm going to use a lowercase r and a lowercase b. So let's go ahead and do the comparison here, everybody. The 3, what letter am I using? Make sure to use the right capitalization. So R or B, capital or lowercase, what am I representing the 3 here with? Help me out, everybody. What are we doing there? Where is 3? What am I representing that with? Yeah, that's a lowercase b. That's a lowercase b. So let me write out the lowercase b. Okay, now let's move over to the 18. Everybody, the 18, take a look at this little diagram here. Am I using a capital or lowercase r or b? Capital B, sounds good. Capital B is what I'll use. Okay, now take a look, everybody. Take a look. I'm not even going to write the rest. Take a look. Do you notice how if I go left to right, I'm comparing a lowercase b to a capital B? Give me a yes or no in the chat box. I'm going from a lowercase to a capital B in this case. Awesome. So what should we expect to make sure that we're comparing the same things in the same way? Should I have a lowercase or capital R down here? Think about the same comparison here. It has to be lowercase. We're going lowercase to uppercase. This will have to be a lowercase r, and this will have to be a capital R. Lowercase b to capital B, lowercase r to capital R. It's just the letters I used, Messiah. So right over here, I just used it to represent each line, and all I got to do is be consistent. And notice the 5, lowercase r, yeah, right there, right there. And then the r over here, I used capital R to represent that, and there we are. But notice in every situation, in all 3 of these setups, we have the same comparison in the same way. Notice over here, capital R over capital B. So we've already used both capital letters, so now we just need to compare it in the same way. R to B, R to B. Look at that. Take a look at this one over here on the right side. We went capital R to lowercase r, so capital to lowercase of the same letter, capital to lowercase of the same letter. So it's all about comparing the same things in the same way. If we can fixate on that, if we can focus on that and master that part, the rest, it will get easier. My party people, is this starting to make a little more sense? Again, you can set up a proportion any which way you like, as long as you are comparing the same things in the same way. You will still get the same correct answer. 30 on this one, 30 on this one. You'll still get 30 over here. because everything is compared in the same way. As long as you do that, the rest is history. So I'm not expecting everybody to get this down in the very first try. Again, that's unrealistic. But I'm going to set the stage here to help you out. Let me just show you again. Compare the same things in the same way, and we will get this done. So there we are, my party people. Feel free, take a screenshot, take a moment, and then we will push forward into the next example. I got your back every step of the way. Don't worry. All right, so moving forward here, let's give this next one a shot. So first things first, let's try this out here. The first thing we should do is read the question first. So give it to me in the chat box. What is it that we are looking to do? What is it that we're looking to find? Give me 1, 2, or 3 words. Keep it nice, short, and sweet. What are we trying to find at the end of the day here? Yeah, we want how many male players. That's right. How many male players should there be? So right here, how many male players should there be? Okay, cool. So I'm going to say blank male players. And again, in the same sentence, we notice that it says, if there are 28 female players, how many male players should there be? So with that said, everybody, okay, I'm going to write that out because it's in the same sentence. So we have 28 female players. We're looking for how many males. So 28 females, I'll write that down there. Okay, cool. So before I continue, what is the comparison that we are looking at, everybody? What are the two things that we are comparing so far? Give it to me. I want you to write it out because I want you to practice saying it and articulating it. What are the two things or characteristics or properties that we are comparing males and females. We can say females to males, but those are the two things that we're comparing. We're comparing male and female soccer players. So with that said, everybody, remember, in order to solve a proportion and set one up properly, we have to compare the same things. So when we are writing our comparison down here, what are the two things that we need to compare? What are the two things? We have got to compare males and females. Exactly, Shantae. So understand that if your question sentence is telling you to find males and it gives you the corresponding number of females, then you're going to aim to try to get males and females lined up in whatever other capacity that they give it to you. And in this case, it's a ratio. Take a look. In a local soccer tournament, the ratio of female players to male players is 4-7. So with that, let's go ahead and see how this is going to work. We see that it says ratio of female players to male players is 4-7. So with that said, everybody, if I wrote down 4 for male and then 7 for female, is that going to work? What do you mean it's not going to work, everybody? What do you mean? This looks so convenient. What do you mean? What do you mean? If I compare the same things in the same way, look, I got times 4, so 7 times 4 is 28. So then if I go like this, 4 times 4, that's 16. The answer's right there, everybody. What do you mean? I'm never wrong. What do you mean? Lies? Lucia, I'm about to kick you out of my class. What do you mean I'm lying? I mean, yeah, I'm clearly lying. I'm clearly being sarcastic. But take a look here, everybody. Take a look. Take a look how you can get tricked here. Has anybody ever thought that their setup was right and they saw the answer that they got in the answer choices and you picked that answer only to realize later that you're wrong? Yeah, this is one of those moments. This is one of those moments that where you think it's convenient, you think it'll work, but if you're not following your fundamentals, you're going to get got. You're going to get frustrated and you're going to make mistakes. We have to compare the same things in the same way. This is not the right setup. Why not? Well, guess what, everybody? Remember that the order matters. The order in which a ratio is read or written, that's the order in which it's supposed to be written down in your notes. It says female to male players, female is first. So the first number, the 4, represents female. That's what we have to understand, everybody. So all of this here, the times 4, that's all rubbish. None of it makes sense. It's not 4 for male and 7 for female. It's 4 for female and 7 for male. Is anybody here starting to feel stronger about comparing the same things in the same way? Is anybody starting to see that? Good. I know it takes time. I know we got to go through some frustrating moments. I understand that not everybody is going to be there at this particular moment in time, but if we're making tiny bits of progress, we will eventually have that breakthrough. I promise. Again, we see that we are comparing males to females, and we want to do it the same way on the bottom so we can write the proportions super easy. Now we just have to be careful about the way that a ratio is read. Because here again, it says ratio of first is female. First is 4. Female and 4, they are together. The second is male. The second number is 7. So 7 corresponds to male. So with that said, now we have the same things being compared in the same way. Male to female, and we can write a proportion successfully. Now, I know some of us might have the question, what if I wrote females first and males second? Totally fine. If you wrote females first and males second, then females first, males second. No problem. No problem at all. Just compare the same thing in the same way. So with that, here we go. And I'm going to answer that last question that I saw a question earlier that I'm going to touch on at the end of here. But here we go. I'm going to write M for males, and let's get this. Let me actually just write X to make things a little easier. Let's set this up. You can set it up like this. You can set it up X over 7 equals 28 over 4. That works. That absolutely works. Because what you're doing here is you're comparing, males to males, females to females. I'm using a capital letter to represent the top comparison, lowercase to represent the underneath comparison. Notice how it's consistent. Capital M to lowercase m. Capital to lowercase f. Nice and easy. You can also go another way if you wanted to. You can compare males to females. That works too. That would be X over 28 equals 7 over 4. It works just the same. Both of these are going to yield the same correct answer. And just for good practice, I would recommend writing it, your ratio up top. This here, I would recommend writing it based on the question sentence. And then the bottom part, I would recommend writing it based off of the information that you're given. That's just my typical practice, but everybody has their own thing about it. So let me go ahead and take this all away. Again, we're just comparing the same things in the same way. So we have males to females, males to females. Or you can do males to males, females to females, like so on the left. Either way will get us, again, the same correct answer. So here we go. Let's go ahead and solve my party people. We can try cross multiplying and dividing, but in this particular circumstance, we're not exactly going to have the prettiest of numbers to deal with. 7 times 28, that's going to be something along the lines of what? 140 plus 50, 196? I know not everybody knows that. So with that, let's go ahead and try to find a more convenient situation. With that, everybody, I think we have a convenient situation right here. How do we go from 4 to 28? How do we go from 4 to 28? Times 7. So if we're going to go bottom to top times 7 on the right side, that means it's times 7, bottom to top on the left side. 7 times 7, my party people, is what? Look at that, 49. 49. Notice how both possibilities were shown in this particular problem. Who here feels like before they absolutely would have chosen 16? They absolutely would have gotten a little confused and perhaps chosen that 16 that was there. Yeah, the setup matters. Exactly. I'm really, really, really happy to see that we're understanding that it's not about the numbers. It's about what the numbers mean. It's about understanding the meaning of the numbers. And that gives you all the power in the world. And so, again, if we look at this setup over here, same deal. We can go ahead and notice that, look, as long as we try to find a convenient comparison, we're good. 4 to 7 doesn't exactly work, but 4 to 28 does. That's times 7. And so we do the same thing the same way. 7 times 7, and that gives us 49. Boom. And so here, I'm going to comment on that, and I'm going to comment on the question somebody had earlier. In the comments here, I see that someone says, I pray the ASVAB is this easy. Well, here's the thing. You're still going to be setting up proportions. The numbers might not be 7, 4, and 28. It could be 12, 18, and 72. But guess what? the techniques that we use are still going to be the same. We can cross multiply or divide, we can simplify first, or we can try to find convenient comparisons. We're just doing the same thing at a larger scale, but you're still learning the proper techniques that will carry you with the numbers big or small to get that same correct answer. So as long as you learn the fundamentals here, you'll absolutely see that translate to the bigger numbers. And that's why during classes, I really prefer to use smaller numbers to help drive the idea across. So that was question number 1. Question number 2 that I want to address is, hey, I saw someone earlier say, hey coach, are we going to be doing questions where we have ratios that are triples? So not like 4 to 7, but maybe something like 1 compared to 3 compared to 7. Yeah, that's called a triple ratio problem, and they are solved the same way, comparing the same things in the same way, and that's going to be the primary focus of tomorrow's class in part 2, where we're only going to focus on word problems the entire class. So I got you for sure. So with that, let's go ahead. All right, so let's give this problem a shot, everybody. Again, it's all about small, simple steps to get to that big understanding. So I'm really happy to see that a lot of us are feeling more confident, but let's keep building upon that. So here we go. First things first, we're going to read that question. The question sentence, everybody. There's no point in reading any of this information if you don't know what it's useful for. So here, if there are 15 banana pieces used, how many strawberry pieces are needed? So again, right there, that gives us a huge clue. We see that we have 15 banana pieces, and it's compared with an unknown number of strawberry pieces. So right here, we can say that we have 15 banana pieces, banana, and then we are comparing that with an unknown number of strawberry pieces. And again, just to be very clear, we are trying to identify the number of strawberry pieces. Do we agree or disagree with that? Yes or no? Perfect. Remember, the first step to successfully solving any problem is understanding what you're trying to find. So boom, step 1, that's a nice check mark right there. Step 2, let's read the information nice and slowly so we can better understand how we can arrange the information. Here we go. In a smoothie blend, the ratio of banana pieces to strawberry pieces is 3 to 4. Everybody help me out. Notice how I wrote bananas first, strawberries second. I could have wrote strawberries first, banana second. Again, it depends on what way the wind is blowing that day. It really does. But the one thing that doesn't depend on the way that the wind is blowing is the main idea. Comparing the same things in the same way. So everybody, if I'm going to compare bananas and strawberries the same way underneath here, what number am I writing down to compare banana? Which one represents bananas? 3. Absolutely. There we go. We're getting it. Now we're picking up on the ratio rule, right? The ratio of bananas go first, strawberry is second, banana is first, 3 is first. There we go. Banana and 3 are synonymous. Strawberry and 4 are synonymous. We're good. So let's take right there 3 banana pieces. Let me use blue for that. And then I'll use purple for the strawberries. We have 4 for strawberries. Everybody, before I continue one more time, does that make sense in terms of what we wrote and where? Yo, I love it. I love it when I see it in the chat box that, in all caps, like, I get it. It makes sense now. Like, this is what it's all about. Thank you for getting me jacked up about being a teacher. So with that, let's go ahead and keep it going here because we have the comparison here. We are comparing bananas to strawberries, bananas to strawberries. We are now able to write down our proportion. And don't worry, even though what we're looking for is over here on the right side, don't worry at all. Watch how I'm going to do this. I'm going to compare bananas to strawberries, bananas to strawberries. Watch what I'm going to do. 15 compared to x, 15 over x equals bananas over strawberries. Again, same comparison, 3 compared to 4. Same things in the same way. Boom. Here we have it. And now we can cross multiply and divide, or we can go ahead and try to find a convenient comparison. So let me show you what that convenient comparison is going to look like. Does everybody here notice that we can absolutely compare? Let me just move this down a little lower. We can absolutely compare 3 to 15 to try to get from 4 to x. Does anybody notice that? That comparison, that convenience there? Yeah, absolutely. But pop quiz, everybody, pop quiz. Let's assume that we didn't have a convenient comparison. What method always works? Go. What method always works? Well, simplification might not always work. Yeah, cross multiplication and division always works. Always. So just I'm making sure to repeat that because I don't want to, trick y'all one way or the other or lead you one way or the other. So here we go. From 3 going to 15, that's times 5. 3 times 5 is 15. I can do the same thing on the bottom then because that's how proportions work. Compare the same things in the same way. So everybody help me out. What is 4 multiplied by 5? D for Duran. I think it's the first time anybody's ever said that in class like that. There we go. Yep, that is choice D. 4 times 5 is 20. X equals 20. That's how many strawberry pieces we had in this smoothie blend. Booyah. There we go. Nice and easy. And here's another thing, everybody. Before I move on to the one more question before class ends, let me go and just show you real quick. Look at how you can compare the same things. I can go from 3 to 15. Look at what I can do. That is times 5. That means I can go from 4 to x times 5. You can notice it without actually writing the proportion. Did anybody here see that? Or is anybody here starting to see that you can solve proportions without actually writing them down? Yeah. So that's how we get to the mental math, by first understanding the main idea. Compare the same things in the same way. If we really start learning that, then we'll start noticing those situations where we really don't even have to write anything other than the information down. And there it is, choice D. So here's what I'm gonna do real quick. I wanna go ahead and give you one more problem. And then I actually first wanna show you a question that we're gonna lead tomorrow's class off with. And it's gonna be this one here. We're not gonna solve this one right now. I'm gonna show this as a little teaser. So if you wanna screenshot this, try to do this on your own and then come back in tomorrow's class and see if you got it done, sure. Let me just go ahead and mark this down as the problem that we'll do first tomorrow. But I wanna go ahead and show you the difference here. Or better yet, I want y'all to tell me the difference here. Everybody, what's the difference between this problem and every other problem we've done today? Yeah, copy it, take a screenshot. But yeah, the main difference between this problem and the other ones is right here. Notice how the ratio says high school to college teams, but what are we looking for in the question sentence? How many teams participated in total? What? We haven't been asked for a total yet. And that's what's going to be one of the 2 other types of proportion problems that we're going to do tomorrow. But I'm going to assure you that we're going to solve it the same exact way, comparing the same things in the same way. I promise you, it's just as easy as the other ones as soon as you reorient yourself with the main idea. Compare the same things in the same way, and I promise you in tomorrow's class, this will be just as easy as everything else we've been doing today. So with that, let's try the other problem that I have prepared for us to finish today's class off. That way we can keep that confidence high. So let's go ahead and crush this last problem of the day. So that way we can, again, get into the next class here with more confidence than before. So here we go. First things first, as always, read the question sentence. So this says, hey, if there are 300 females, how many males? How many males at this local YMCA? Okay, we have 300 females. How many males? That's what we're looking for there. So let's just write that down. 300 females right there. And then we have blank number of males. Okay, so remember everybody, the way that you're comparing what you're looking for is the way you're going to want to compare your ratio that you're given. Keep that in mind. I'm going to reiterate this. I'm going to say this again and again tomorrow as well. How you set up the question sentence is how you're going to want to set up the ratio. Let's go ahead and see what I mean by that. So here it says, Hey, the local YMCA, there are 18 males for every 20 females. Okay, cool. So I'm going to write 18 males for every 20 females. Everybody, what's wrong with this already? I wrote the information down exactly as I saw it. 18 does correspond with males. 20 does correspond with females. I wrote down the right information. Correct. I wrote down the right information, but I wrote it down in the wrong order. Remember, everybody, compare the same things in the same way. One more time. Compare the same things in the same way. So let's do that. Let's take the 18 males and put it under the blank number of males. And let's take the females. And now look at that. Females compared with females, males compared with males. Now we're in a good position. Now we're good. So let's go ahead here, place an X for the males, and let's just set this up and solve it. We're good. Let's send it. So here we go. I'll just go ahead and compare it like this. I'll just do it in green. Females to males, females to males. So 300 over X equals 20 over 18. All right. So everybody, we have ourselves a situation where if we were to cross multiply and divide, I'm looking at this and I'm just saying, oh, hell no. I'm not going to try to do this massive multiplication and then divide by a pretty large number. Look, I'm a teacher. I've been doing this for over 10 years. I'm looking at that and I'm saying no. Let's think about the other two ways. Well, we've been typically doing it by comparing in today's class, but it may not be obvious how to go from 20 to 300. So for some of us, that's out of the picture too. But here's one thing that would work: simplification. Let's try that out. Everybody, do we see how we can simplify 20 over 18? Yeah, I think that's worth a shot. And again, this is all happening in 5 seconds or less. You might want to look at this and say, nope, not cross multiplying. Nope, can't compare. Oh, I can simplify. That's how it goes. Like, it has to be that fast. And so once you decide, go for it. So let me zoom on in just a little bit here. Let me move this over to the right or to the left, and let's simplify. Everybody, what number can go into both 20 and 18? What can we divide out of both 20 and 18? Yeah, we can divide 2 out of both. So let's divide 2 out of both. And let me show you where we get to. So we still have the 300 over X. And on the right side, 20 divided by 2, that's going to be 10. 18 divided by 2, that's going to be 9. I'm looking at this now, and I'm looking at this and I'm saying, oh, this is actually kind of easy now. This is actually kind of easy because, everybody, if I now try to compare, I'm trying to get to X, I can try to compare vertically, which not going to work, but I do notice that if I try to go right to left, I can do that. Everybody, how do I go from 10 to 30? How do I go from 10 to 30? Multiply or divide, and by what number? Multiplication, that's correct. Not by 3. 10 times 3 is 30. What, we have to add another 0. Yeah, times 30. 10 times 30 is the right way to go because 10 times 30 is 300. We've confirmed that. So that means that our correct answer is going to be 9 times 30. And everybody, 9 times 30 is the same as 9 times 3 with an extra 0 at the end. What's 9 times 3? 27. So 9 times 30, that's 270. So even a problem that looked intimidating in the beginning, numbers-wise, we were very much so able to reduce the complication and give ourselves an easier path. And guess what? This wasn't the only way to do it. There were plenty of other ways. It's all about getting enough practice to get yourself to a point of confidence with each specific technique, everybody. That's what it's all about. That's what it's all about. And this is just one of the many units and lessons that this test has to offer. Proportions is just one of them. We have other things. We've got percentages, we've got distance, rate, time, we've got volume, we've got area and perimeter. We have all of these things that can all follow their own main ideas, their own techniques, that if you practice it properly for enough time, you're going to feel just as confident there as you are hopefully feeling here. So with that, we are going to be looking forward to the next class coming up for Ratios and Proportions Part 2, where we're going to be dealing with two new types of proportions. One, the part to total. So these are part to part, males to females, red to blues, things like that. But we're going to be dealing with part to total, and also we're going to be dealing with triple ratios. But again, they're still going to fall under the same main idea, and we're going to kick butt just the same. Thank you guys so much for showing up. I'm Coach Anderson. Thank you again, everybody.